Welcome to the first official book review video. And honestly, I wasn't expecting my, I don't know what you call it, book stack video where I had like 50 books stacked up that high to do like at all that good. So I think what I'm going to do is just obviously keep these casual, just like my other videos, but just walk through like all the books I've read individually and then parse out all the basically the sticky notes of content that I've identified over the past 4 or 5 years, put those on a point on the side, and then talk about them with pseudocode, with architecture diagrams, and do that book by book. So the first book I want to start out with is this book. It's called Acing the System Design by the author Tan, and it's from Manning Publishers. This book I want to start out with because I think it's a good introductory book when we start to talk about software engineering. And I've identified 3 points that I had wrote on my sticky notes on the left here that we're going to break down. The first one is interview the company. Second is distributed transactions, the saga pattern. The third is load balancing. And the bottom, I'm going to give it a score, 1 out of 10, and that's called my fluff meter. Fluff, unfortunately, is a symptom of a lot of books today where they're unnecessarily lengthy and they don't really have a lot of content, and I call that fluff. If something's kind of just inflated for no reason, artificially inflated, it's fluff, right? So it's going to get a fluff meter. On this scale, 10 is how should we do this? Actually, we have to create the meter. So a fluff meter would be 1 is the we'll just do 1's the worst, 10's the best. My fluff scale. I'm gonna change that word to scale, fluff scale. So 1 to 10, 10 being the best, and that's our scale. So the first point here, where we talked about interviewing the company, is such a critical part of software engineering, and I just don't hear it talked about that much. It is so important because when you're looking for a job, people have this notion that, hey, the company is interviewing you, but the other side of the coin of that is you are also interviewing the company. So when we talk about interviews, there's a couple key questions that you absolutely need to ask when you're, looking for a job. You want to hear what their deployment schedule looks like. So let's actually label this here questions to ask in interviews. You want to ask them what their deployment schedule is. The reason for that is because you're trying to figure out if there is any after hours time. And some people like that, right? Some people thrive on like fast and frequent deployments. They don't mind putting in additional time, whatever. But some people don't like that. So you got to figure out, like, hey, is the team that I potentially am going to join, do they have like a schedule in effect that, fits you? And you really got to make sure that you ask this question to the dev team or somebody who is not HR, because you want to find this out for sure. And you'll find that a common theme you'll see is most of these questions you want to have targeted to the dev team, not the manager of the team, but the developers on the team doing the deployments. It's very, very crucial. The second one is the on-call rotation, and this is something that does not want to be talked about because nobody really wants to have this, but you want to make sure that you understand what this looks like and what this actually means. Because if we see here, if you have after hours deployments, but then you also have, you're on call for that week or 2 weeks or, month, that's going to lead to not only more stress on your part, but it's going to lead to a lot more time worked. But again, you need to ask this to the developers. This is very critical. So the book goes into these kind of things, but this idea of interviewing the company, you have to, in my experience, you got to make sure you ask these questions because you're trying to, again, how many extra hours of time are we going to have to work? And then the next one is going to be who assigns tasks. And this might not be anybody. And where you're trying to get with this one is that will you be creating your own work? And so, whoa, did that just change color on me? Oh, I think it picked up a style. I guess we're doing YAML. We'll keep it. We'll keep it. If you ask the question, who assigns tasks, that's going to be important because it's going to get to the root of, am I creating my own stories, or is somebody else going to be writing that and giving me the information, or am I going to have to go and source out all the information? Because that in and of itself takes a lot of time to do that. So you just kind of want to get a feel for, hey, like, this is the general flow of, this is the start of sprint, and this is how we decide what's, what work we're bringing in, what's being prioritized. And so it's very important because if you're somebody who likes to operate with a high level of autonomy and a high level of unsupervised work, meaning you just kind of know what to do, you're not going to operate well in an environment where you're being heavily micromanaged and constantly just assigned tasks with no real, freedom there. Now, some people might like that setup, right? They just want to get in and pick up what they're assigned and work it and deploy it, and then that's it. Some people, that's how they operate, but other people, that's not going to be the best fit for them. So you just want to get a feel for, like, what is the team doing now? Because you don't want to join the team and think you can change it just, out of the blue, being the new person. You want to see, okay, like, here's what they're doing currently. How do I, like, assimilate to that? And, if you want to then go about proposing changes or suggestions, so be it. But you don't want to rock the boat a ton when you just join, right? Because you're going to be heavy in learning the system and getting up to speed with all the extra administrative stuff. So that's definitely a question to ask, right? Is who assigns the tasks? The next one is going to be you're just going to want to ask a very open question, but just go through what meetings are typically on the calendar for a given week, right? You're going to have your stand-ups, that's a given, but you're going to want to figure out, okay, what time is set aside for story creation, estimation, prioritization, any kind of, like, general research time, is that being prioritized? So you just want to get a feel from the developers, like, on a given week, on average, what does the meeting schedule look like? And how many hours in a given day or week are filled with meetings? And how much, like, just general context switching is there from, thinking about a problem or coding to then, having to jump and go into a meeting. So those are the kind of things you're going to want to, deduce from these conversations. But those are really four big ones. Especially, I can't stress enough, like, the first two, because that's just something that you want to figure out if it's the right fit. Because if you're somebody who, let's say, it has this very strict, like, hey, this is, like, when I stop working, or this, or just generally very busy with things, you might not operate well in a team that demands a lot more time put in beyond the, traditional 40 hours. That's not a knock on anybody. That's just some people just have different things happening than other people, and you just want to get a feel for like, is this team that I'm joining, like, does it match let's say the stress levels that I'm trying to fit to, right? Because if you join a super high stress, fast paced team, and that's not really what you're wanting to work in, you're probably not going to like it. These are the kind of things you have to figure out ahead of time, right? You have to ask. And honestly, I would ask these questions a couple times because they can change based on the person you're talking to. Unfortunately, in interviews, everybody's trying to make it sound good, but you have to get to the honest and genuine answers, and those are hard to come by, unfortunately. So you have to ask a couple times just to, build your, you know, information about what you're trying to get, right? So you have to get the answers just like they're trying to get the answers from you. So interviewing the company, very important. So apart from this, we're going to jump to more technical now, but we're going to go into distributed transactions, and the book talks about the saga pattern. It talks about, I'm not going to be able to spell this, choreography versus orchestration. Introduces things like, two-phase commits. Introduces queues, logs, streams. We can just say queues. How about queues and logs? That pretty much sums it up. And databases. So when we talk about distributed transactions, what should come to mind, and I guess I should have wrote this as A, is going to be the concept of microservices, right? Like small, independently running services that, I guess by practice, should have their own database backing that. And the idea of distributed transactions is that if you have one initiating microservice that kicks off a process and it goes to microservices B, C, and D, a distributed transaction is the concept of basically like if microservice D fails, then B, C, and D will all roll back their respective changes and return, whatever error back to microservice A. So in practicality, what this looks like, and we're going to pull up freeform here. So if I have we're just going to call this service A, and I have service B, B, C, and D. And what's going to happen is that service B is going to kick off its event. And you could have a thing like, service B could respond, and then it's going to reach out to service C, and then service D. And then each of these will have their respective databases that they are communicating with. That's the basic flow. Okay. So you'll see something similar when it talks about a saga pattern. So let's say service A kicks this process off by sending the message to service B. Service B will then move its message over to the database, persist it there. return a response back to service A. It's going to go back to the next one to service C. It's going to persist, the state inside its database. Jump back to here, and then finally service D. Now, if this fails here in service D, this can bounce back to service A, and it will effectively, say, okay, we need to roll all this back here. We need to roll all the events back and finally return back to service A with said failed message, right? So this also gets into the topic of if you don't want to have, or you could introduce, I need a good shape for a queue. Basic, we'll just do it. I kind of want to use I guess we'll use a triangle for a queue. Okay. So you could have queues in between that, but you need some kind of orchestration tool in that event. But anyway, so distributed a saga pattern is difficult to implement correctly because it deals with, okay, how do you roll back changes across a distributed system? So how does D, C, and B all roll back as changes if service D is the one that fails, right? Indicating that whatever operation that was supposed to happen across your system failed to happen, but we want to revert state. We want to roll back that transaction, essentially. And this also kind of gets into the topic of okay, well, two-phase commits are another thing you'll hear about this, but two-phase commits, if you think about, I'm actually just going to copy this down here. And let's delete some of this. Okay. All right. Say we have service B and D. What can happen is service A can initiate a begin transaction statement to both service B and D. That's then going to respond with, for lack of better words, the OK back to service A. Once service A receives both of those OKs, the transactions are, we've begun both transactions on both B and D. We can then perform, okay, now we can draw another arrow to say, okay, now we can commit our work. So we'll say commit. Okay. So it's really a two phases because first phase begin, second phase, and then commit. So if either of those fail, let's say service B commits fine, but service D fails to, commit its transaction and rolls back. Service A will be notified of that, and we can roll back service B's. So it's just a multi-step way of handling transactions because when you have a distributed system like this, you have to make sure that your microservices are staying in sync, for lack of better words. You have to make sure the state is okay, right? Because if you go back to the top here, and let's say we had some data element, 1 that is now in database 1 and 2, but service D failed, this database is not going to have the data that it needs, and then these databases are going to have essentially just stale data that's going to be in there that needs to be deleted. So when we roll back, this distributed transaction, this data is going to go away too, so that way the data is all now delete it from the database, and we're in a good, healthy state. Because if you get data that is just dead data, poison data, and you just let that persist in your databases, not only is that going to take up space, but after a while, it's potentially going to affect and degrade performance. Because if you have some pretty serious queries with maybe joins, full table scans, or you're doing some heavy filtering, if you have a lot of, the more data you're going to add to that, it's just going to detract from performance. And you might have to revisit, your indexes. Your writes are going to get slower depending on how how many columns you're indexed on. But it's just going to cause a mess. So when you distributed transactions, again, a way to maintain healthy state in the system. There's more to be said about that, and there's different, styles. Again, like choreography versus orchestration. Choreography is going to have more of like a, you'll see with a number of like queues kind of acting as a request response model, and you're going to have the queues or topics are going to house the response from a receiving API. The consuming API off that is going to get that message, then send it over to another queue that's going to have the next service as a consumer of that. So it kind of zigzags back and forth across queues or topics, whatever you're using. Choreography is more of orchestration is more of like a centralized service that does that. But again, we went through two-phase commits, queues versus logs. So the book specifically is going to talk about different styles of message brokers. Like you can think of RabbitMQ, you can think of Azure Service Bus, you can think of Kafka for your log stream. But it's going to go into that, and it's going to go into databases. So relational versus NoSQL, that's going to be included in there, and it also goes into cache. I should say. So different topics like that. The last thing I do want to bring up is point number 3 that I've highlighted in the book, and that is about load balancing. So if we jump back to our diagram here, so I'm going to copy this down and put that down there. I'm going to actually delete the other services, and we'll just think about it in the context of service A and service B. And I'm just going to now, oops, not that. Going to now just copy an arrow down here just to signify that service A talks to service B. So nice and simple. But what if service B needs to scale? So we're going to say, okay, we're going to scale service B out to 3 instances. So now we're left with the question, which instance does service A talk to? Do we want to point it directly to, service, this instance of service B, this one? How do we distribute traffic if we're getting, 150,000 messages? How do we distribute 50,000 messages somewhat evenly across these 3 instances? How do we do that? And that's where a load balancer is going to come into play. So let me do this here. So a load balancer, we're going to hit our load balancer. A load balancer is going to do is distribute traffic evenly across all the instances that it's configured to use. So I'm going to name this load balancer. So the load balancer does that work for us, and it's very important in a scalable system, because if you don't have a load balancer, you risk all your traffic being directed at only one instance, and that obviously is bad for performance but also scalability, because that means if you add an instance, you're essentially not doing anything because all the traffic's going to the top instance. With a load balancer, it takes care of that for you. It's going to distribute traffic relatively evenly across all your instances. And if we have it configured, we can just add another instance and wire it up to the load balancer, and it's going to work accordingly. Now the book goes into you have hardware load balancers, you have load balancers available through AWS that you can use, but the book goes into some of that. But this is the general idea. So whenever you're going to hit your load balanced URL, it's just going to give you basically the pathway to whatever DNS routes you have attached to that. So we can think about it: service B1, instance 1, service B, instance 2, and 3. So and I should say, if service B2 goes down, your load balancer is going to handle that accordingly. So it's just going to continue routing traffic to instance 1 and instance 3. So very, very powerful. It's necessary in a scalable system, and it's just a key piece of system design that you're going to come across in the book, and that's why I included it here. But obviously, you can go way more in depth into load balancers. But once they're configured, and once you have it all set up, you're gonna be in a really, really good spot, because it's going to allow you to scale, and it's necessary in a scalable architecture. So that's really all I have for load balancing. But those are the three main things I got from the book. There's way more in here, but that's just 3 things that I pulled out. So I do want to give it the fluff scale, and I am going to give this book a solid 8 out of 10 on the scale. The reason I don't have it on the top or higher, 9 out of 10 or 10 out of 10, is I felt like it could have actually been a little bit more technical, just a little bit. It was abstract enough, I felt like, for a system design book, meaning like it introduced all the core and major topics, but I felt like it could have maybe gone into a little bit more technicality in terms of like performance benchmarking that would lead you to make these decisions, because I feel like that's some of the harder part about system design is like, okay, I get that we have all these tools at our disposal, but what is driving us to pick one versus the other? What's driving us to make a decision about, whatever component we happen to be talking about? And there's books written about that topic that we're going to get into. One of them is it's called Performance and Scalability. But benchmarking is a massive topic, and it warrants a lot of time because it's necessary, because it makes us choose informed, and make data-driven decisions, and that's where. So 8 out of 10. But I will say this is a very good system design book, and 8 out of 10 is in my opinion, is a very high rank to give it. But that's all I got for this video. Again, Acing the System Design interview by Ziyong Tan by Manning Publishers. So that's the book. So thank you all for watching. I'll see you in the next one.